We're living in a mysterious universe that is much more astonishing than we think. Not only is it mysterious, but the cosmos has much more to explore beyond a common man's imagination. Stephen Hawking predicted decades ago that there's alien life for sure. But apart from life, the birth of space research and the rapid growth of technology have led scientists to discover a very mysterious and eye-opening structure at the edge of the universe. And all this has been possible because of the stunning approach of the James Webb Telescope. What's special in this discovery? How big is the universe and what's more to discover? In this video, we'll dive into the space and find answers to these questions. How big is the universe? In 2013, the Planck satellite mission of the European Space Agency published the most exact and detailed map ever created of the light that has been the longest in the history of the cosmos. It was discovered by using the map that the age of the universe is 13.8 billion years. Charles Lawrence, the U.S. project scientist for the mission at NASA's Jet Propulsion Laboratory in Pasadena, California, said in a statement that the cosmic microwave background light is a traveler from far away and long ago. And because of the relationship between distance and the speed of light, researchers can observe a part of space that is 13.8 billion light-years distant. The fact that astronomers on Earth may swivel their telescopes to stare at 13.8 billion light-years in every direction places Earth within a viewable sphere with a radius of 13.8 billion light-years. This is like a ship sailing over an empty ocean. However, even though the sphere's diameter looks over 28 billion light-years, it is far more significant. This is due to the expansion of the cosmos is something that scientists are aware of. Therefore, even though astronomers might observe a location that was 13.8 billion light-years away from Earth at the moment of the Big Bang, the universe has continued to expand throughout its history. According to a piece written by Ethan Segal for Forbes, if inflation occurred at the same rate throughout the life of the universe, that same spot would be 46 billion light-years away today. This would make the diameter of the observable universe a sphere with a circumference of approximately 92 billion light-years. That means scientists found the relationship between a galaxy cluster's brightness and its X-ray temperature and found a strong correlation between them. It seemed as though certain clusters were traveling at a different pace than others since they looked less light than predicted. According to the European Space Agency, ESA, this perhaps unequal influence on cosmic expansion may be produced by the unknown dark energy. If a sphere were to be centered on the location of Earth in space, it might give the impression that people are at the center of the universe. On the other hand, much like that ship out in the middle of the ocean, we have no idea where we stand in the immense scope of the cosmos. Just because we cannot see land does not indicate that we are located in the middle of the ocean, and just like we cannot see the edge of the cosmos does not mean that we are at the center of the universe. There are a plethora of various methods that scientists use to calculate the size of the cosmos. For example, they can measure the waves that come from the universe's beginnings and fill the cosmic microwave background. These waves are called baryonic acoustic oscillations. They can also make use of standard candles, such as type 1a supernovae, to determine distances. However, these several approaches to determining distances might supply the answers you're looking for. How inflation is shifting is another puzzle. Many researchers think that the pace of inflation is decreasing. Even though the number 92 billion light-years was derived from the concept of a constant rate of inflation, if the expansion of the universe occurred during inflation at the speed of light, then the answer should be 1023, which is equal to 100 sextillions. dark energy events may have affected the universe's expansion in the moments immediately following the Big Bang, as suggested by NASA in 2019. Instead of using a single technique of measurement, a group of researchers from the University of Oxford, led by Miran Vadanian, conducted a statistical analysis of all the data. Bayesian model averaging is a statistical technique that was developed by Bayes. They discovered that the universe is at least 250 times larger than the universe that can be observed, equivalent to a distance of at least 7 trillion light-years. What the James Webb Telescope already discovered about the universe. The ability of the James Webb Space Telescope, JWST, to go back in time to the early cosmos and observe some of the first galaxies and stars is one of its most prominent features. Already, the telescope, launched on Christmas Day 2021 and is currently located 1.5 million kilometers from Earth, has explored the most distant and oldest galaxy known. The telescope zoomed in on a faraway galaxy in the photograph to get a better look at it. The galaxy in question was a smear of light that appeared 700 million years after the Big Bang. The JWST spectrograph identified the presence of heavy elements in the galaxy, particularly oxygen. However, scientists hope the telescope will find an absence of heavy elements in even earlier galaxies. This would be evidence that these galaxies contain only population 3 stars, the stars thought to have been the first stars in the universe. These stars are considered enormous and made entirely of hydrogen and helium. Galactic structure. JWST has already supplied scientists with data that will be extremely helpful in their quest to understand the structure of galaxies and how stars develop inside them. Janice Lee, who works at the National Science Foundation's Noya Lab in Arizona, is in charge of an observational program that searches galaxies for recently formed star clusters. JWST observed a galaxy 24 million light-years away called NGC 7496 on behalf of Lee's team. This galaxy's young star-forming regions had been hidden from view up until this point because Hubble's instruments could not break through the dense dust and gas surrounding them. However, JWST can detect infrared light reflecting off the dust, enabling the telescope to investigate events that occurred very close to the time when stars first turned on and nuclear fusion began in their centers. According to recent research findings, astronomers may be misinterpreting the measurements of exoplanet atmospheres obtained from the James Webb Space Telescope by an order of magnitude. The ambitious objective of the telescope in deep space involves making measurements of the chemical compositions of the fascinating stars, galaxies, and nebulae that it observes. For example, these new photos of infant stars in the Orion Nebula were revealed earlier this week. Scientists working with telescopes utilize complicated models to assist with interpreting exoplanet research. However, a recent Massachusetts Institute of Technology (MIT) study discovered that these models do not have the precision necessary to highlight Webb's subtleties. The James Webb Space Telescope has made groundbreaking discoveries across the cosmos. A deep space telescope discovered an exoplanet almost 20 times the size of Jupiter to have signs of silicate-rich clouds. The brown dwarf size is comparable to Jupiter's. The brown dwarf is known as VHS 1256b, located 72 light-years away from Earth in orbit around 2 minor red dwarf stars. Webb-sensitive equipment also showed previously undiscovered detail in a gas cloud referred to as Doradus 30, which was at first given the nickname Tarantula due to its spider-like look. The Tarantula Nebula is the brightest star-forming area in our neighborhood other than our own Milky Way, which is located 161,000 light-years distant in the Large Magellanic Cloud. Galaxies with a redshift of 13 were discovered by researchers exactly 1 week after the James Webb Space Telescope shared its first scientific photos with the public. This redshift corresponds to about 300 million years after the Big Bang. Not long after that, new data suggested that astronomers are shooting beyond that threshold with possible detections up to redshift 20. If the theory is correct, those galaxies existed just 200 million years after the Big Bang, making them among the earliest in the universe. After that, Webb shifted its focus to the most distant star, which was given to the name Earendel in honor of a figure from J.R.R. Tolkien's precursor novel to Lord of the Rings, The Silmarillion. The light from the star took almost 12.9 billion years to get to Earth, but is now visible in a little bit more detail than it was in previous imagery from a deep-field photograph taken by the Hubble Space Telescope. Webb also saw a galaxy in the shape of a wheel, which he dubbed the cartwheel, revealing an unparalleled level of detail in the galaxy's structure. Webb could find individual stars within the galaxy's star-forming regions by using infrared light. He also found numerous young star clusters encircling the supermassive black hole at the center of the universe. These regions are covered in dust, and the best way to see them is with infrared light, which can see right through it. Do you agree? Do let us know in the comments below.